on by what I assigned last time. So you brought up you had a question. Would you like to? We'll start with Daniel first. You had the 0.3 comma -4, I believe, was one of them. Okay, so Daniel, that's down here. So there's my location, correct? I need to put it in polar. Remember, polar is r theta, correct? Really easy to find r because all I got to do is draw this triangle, correct? Where this is 3, this is -4, this is a right triangle. How am I going to find the other part? Good old Pythagoras tells me 9 plus 16 is 25. The square root of 25 is 5. So there's my radius. You good there? All right. Option number 2. Well, not option number 2, but the other part I need to find is theta. How can I find theta with just y and x? Because I want to only use y and x because that's what was given to me, right? Tangent. So tangent of theta is -4/3. So this is where using your graphing calculator comes into play, is just taking the arctangent. They might ask you to do it a different way, but this is basically saying where does arctangent or theta equal -4/3. So can you quickly, everybody's going to need their calculator out, so you might as well get it out today. We are almost 100% calculator today. It doesn't necessarily, because this is not a perfect unit circle. 3/4 is not on the unit circle, or 4/3. Does that make sense? So as I do so, this is in radians. And what did we get when we did the arctangent of that value? -0.26, 0.926, so we'll go -0.93. Now, Daniel, to be honest with you, that could work. That could be our answer, because that angle is in quadrant 4, is it not? But also part of your homework was asking, where is this other location at? What could I do for other locations? Well, once again, we all know, I don't know what you guys can really see. Does that look like a different color? We know, Daniel, what that angle is right there. If this is -0.93, how much is the whole way around? Exactly. So that's 6.28 minus 0.93, and I get 5.15. Yeah, because we just need to be in polar, don't we? And that 5.15 you need to understand is just in radians. Does that help you out? Either or. I'd prefer the 5.15, but could I really refuse you on the other one? No, because it's the same place. Does that make sense? Now, the thing that we were talking about last time, what if I was up in quadrant 2 with those same values, but we just flip-flop them a little bit? So therefore, this is -3, this is 4, right? We still have the same radius as 5 up here. Would you guys agree with that? Okay, but what's our radian? Well, if I still did it, it'd come out -0.93, but that's located right here. Would you guys agree? Is that where we're standing for that point? So what do we need to do? So I need to say, oh, well, this right here is a reference angle of 0.93. And I want to know just this part right here, correct? How much is this? Pi, so we're going to go pi minus that 0.93, right, which is 2.21. Right? And that would be that location. So everybody good with me? Are we all understanding when we go from from rectangular to polar, the two equations that we're using really. But if we draw the triangle, it's already stuff we've already done. We just got to think about it a little bit deeper, don't we? But that's how we get our r, is by doing Pythagorean theorem, because that's what the radius is, correct? And then notice here, tangent of theta, by the way. Are you writing these down, Miss Hadley? Might be good to write them down. Or are you just going to watch them? Okay. But tangent is y over x. And notice that will help us out. Just make sure your angle that you're in is in the right quadrant. Correct? Okay. I was just going to talk to you guys about something, but I can't remember what I was just going to say. Oh, the other thing is, one more second, and then I'll talk. Is everybody here today? Are we missing anyone? Can't see Bryce. Is Bryce here? Oh, right there. You were hidden behind Daniel. Sorry. Okay. I've already kind of told you the test of stats. My average is pretty high because it's if you should know how to do this, right? So I'm hoping it's a grade booster. Me and Miss Christensen talked, and I don't know if I'm doing a group test yet, where you get a I'll have people randomly come up and you have to pick a name out, and that's your partner, or you get to use your notes. I don't know what I'm doing. I'm going to do one or the other. So make sure your notes are good. Not on the stats test, because the stats test is, but on the polar one. Because my goal is I don't want you guys to retake that test. I want you to retake. If you're going to do it, let's get on it. Let's get going so we get that retake out of the way so that we're not playing last quarter games. You know what I mean? So come in. Let's get your stuff going. Remember, if you do want a higher increase just for doing your test corrections, that's due by next Tuesday. Okay, is everybody there with me? And I will not be here for your guys' class on Tuesday. So you could work it in class because you're going to have the review, which you could probably finish in class and then do test corrections. That could be something for you. But I would really like you guys to jump. Lily's already taken it. How was it? Not too bad, right? So if you want to retake a test, I'm really hoping it's going to be test 1 of the quarter. Does that make sense what I'm trying to go for there? If you want to retake it, let's start getting on that so I don't play this game at the end of the quarter stuff, okay? Please. Now, that time I did. Other times I wasn't. Yes. No. I'm going to choose what I feel. Miss Christensen, I think, is going to do it as a group test, but I don't know if I want to do that yet. That still makes me like, ugh. So I think I am leaning towards notes personally. But so just make sure those are good so that if you need them. But obviously, when you do a notes test, go for what you know already, right? Pound through it. And then if you get stuck, you're like, all right, I'm going to go back and look at an example. Yeah. Does that make sense, though? It's kind of like that note card. If you guys really knew what's on the note card, how many of you guys really looked at it? It was available, but know your stuff and you'll be good. Does that make sense? Okay. All right. Any more other ones that we need to go over? Yes, sir. Polar rectangular. So I'm just going to write one up here, or do you have a specific one? What does it say? And that's in polar? Oh, so this is polar, not rectangular. All right, I just want to make sure, because obviously. So the key thing for polar to rectangular is x equals r cosine of theta. So do I have an r? Yep, put it in. Do I have a cosine? I mean a theta? Yep, put it in. Put it in your calculator. Boop, there it is. Now that's your x. Then y would be, oh, do I know my radius? Yep, plug it in. Do I know sine of this angle? Yep, plug it in. Does that make sense? Pretty simple. Just going from rectangular to polar is polar to rectangular is probably the easiest method because it's just a plug and chug. You know what I mean? Yes, ma'am. Okay, good question. So let's say, what if we're here? My reference angle is the angle, right? So what if I'm here? Well, here's pi, and I got to cut back that reference angle because I'm in quadrant 2. If I'm in quadrant 3, I'm going to go pi plus that reference angle. Make sense? If I'm down here in quadrant 4, I'm going to use 2 pi, cut back that reference. Does that help you? Just a visual, and it should help you in that. Yeah. Anybody else? I'm going to have you guys hold on to the homework because I'm adding homework to it. Did I just show you guys that? These problems right here are going to be added today or next time. It depends on if we can get to them today because we are shortened by some time. So if I can get to those, we are going to be added on and you'll be due next time. But if I cannot get to those, We're still going to hold on to your polar and turn them in one after we get to those other 7 questions that I've taught you. Does that make sense? So it all depends on time. I guarantee I can get them by next time because obviously it's a longer time period next time. And so far, just for you guys, just to let you know that our sophomores, the stuff that is being covered in class is the statistics. And by the time I get done with statistics, you guys have been coming back in. So does that make sense? A lot of my kids have been done in 40 minutes, and you have 90 minutes to do it. So, just saying. Okay, does that make sense? So it's Pearlie, Lily, Daniel, and Caitlin, right? Any questions for that? Okay. Are we all good right here really quick? I have to put you in another room just because there's other people, but I just put you in Miss Wilkins or Mrs. Kate. I don't know, somebody else. Just because I don't have enough to have a set. So I just got to move you to where the computers are. And I take some of their juniors usually so that we can swap. All right, everybody ready, rock? Have I already been recording? Oh, yeah, nice. All right, cool. Whatever. 8-1. Once again, this is a computer day. This is a computer, not a computer, but almost pure calculator. But if I write it up on the screen, you should still write it in your notes as your example. Our example today is going to be shoe sizes, though. That's our data. That's what we're going to gather. So, ladies, if you'll subtract 2 from your shoe size so that we're all in men's. Or actually, let's do this. Since I've been doing ladies put it in men's. Men, we're going to put it in ladies. So we're going to increase our shoe size by 2. So therefore, that means I would be wearing a 13 because I wear an 11. Does that make sense? Okay, Nay, you wear a 7. We're going to do it in women's. You still, that's what you told me. Okay, all right. Thanks, Nay. Shay, Littlefoot, what size? Yeah. No. Yeah, okay. McKen? 7. Brady Lake Williams? You wear a 12? You guys should be writing this down. So we're going to go to 13 for you. If you have a half size, just round up, please, just so we're all just nice and willy. Okay, Dunk? Okay. Kaylin? You wear an 11? You have a hard time finding shoes? My wife wears an 11 and she's always frustrated. Larissa? Had? Daniel? Daniel, you only wear a 10? Trekkie? Will? A 5? Okay, we'll put a 5 down for you. You're pretty small, so I'm guessing it's on the lower end. Where are we at? Chris? Three? All right, so those are our shoe sizes, okay? Everybody in this classroom is a shoe size. Now, my first period class, okay, let's say all of a sudden Shaq walked in. Okay, in women, Shaq would wear a size 25. Okay? Anybody remember what that would be called? It's an outlier. That would skew our data, wouldn't it? It's okay, but still, it's at least a shoe. It's a big shoe, right? You get an understanding that that would be an outlier. Definitely would skew our data, wouldn't it? Okay. Now, somebody had me, because I had Jared Gibby. He's pretty tall. He had a size 16. And somebody's like, what if Jared Gibby went to a first grade class? He would definitely be an outlier. He actually was not an outlier in my class because we had a 13 and a 14. So really, he didn't skew our data with a 16, did he? But that was at first. I only had all boys and one girl because all of my sophomores, as we took it, I guess it must be a junior class of boy and one girl. That's all there was in there. So everybody else was 9s, 10s, and 11s and higher. And then there's the one girl, and she was size 4. So would she have been an outlier? Yeah, and then I'm like, okay, because other classes were in here. Then I'm like, all right, I'm going to do everybody because to get some more females in it, right? And then that didn't make her an outlier anymore because those other people's shoe size kind of represented of where she was at. Does that make sense what I'm saying? So just remember, something can be an outlier if it really skews your data. Correct? Everybody remember that term? Okay. With that being said, okay, here's our data. We're going to find mean, median, and mode. Now, is there anyone in here that doesn't or haven't heard of these before? Most of you guys should have known these somewhere. Right? Can somebody tell me what mean means? It's the average where we add them all up and divide by however many there is, right? Median, middle number. Okay, so what if we have an odd amount? Is there going to be a specific middle number? Yes. What if there's an even amount? We will not have a distinct middle number. So what do? We take the innermost two numbers and do what? Take the average. Does that make sense to everybody? Hey, you have a great one. Nice. Well, good luck to you. Have a good weekend then. All right. Awesome. Now, here's controversy, guys. Mode. What does mode mean? The most. I like to say more just because then I switched the D with an R. That's how I remembered it. I remember mean just was average. I don't know how I got that, but median, medium pizza. So it's the so you're mean because you have to add? Oh, okay. Anyway, here's the controversy. There are some people that say that there's only one mode. Let's say, for example, there's like the shoe sizes here. So we have quite a bit of 13s here. And let's say size 14 just had the same amount. Some people say then there's no mode. And there's statisticians that fight this all the time. Because they have different definitions. Mode means most. So if they're equal, is there really something more than another? Does that make sense? How some people believe there's no mode, but we are going to say if it's just whatever number or numbers that have the highest amount. Does that make sense? You could have 7 modes if they were all the same. Then they would all be a mode. Right? Daniel? That's why there's an argument. Exactly. That's the whole thing. If there's not one happening more than another, how could you say that's I kind of swing with there shouldn't be a mode. I'm more one of those people. But there are people that say that it can have multiple modes. So I just want to keep that out there. That's what we will be testing on is multiple modes. That's what you need to care about. Now, if you guys get an AP Stats, maybe you guys could get a little deeper in that, right? Make sense to everyone? Anybody taking AP Stats next year? None of you? Okay. Awesome. Are we okay? Are we ready to rock? Let's get out our machines now, okay? Everybody have their machine? Would you like a machine to play with? Or do you have yours? Okay. So would you like one? Which one do you have? Yeah, that's basically that. What the heck? Rugby. Thought you'd catch things. I thought you did.
Why are you likely to defend that?
Thought you told me that. Oh. What's up, brother? What? So we're going to go into this. So I'm going to show you. So I'm showing you on a TA84, which is very similar to it is the 83, except we're going to have to do a little bit different. Who is my 83 users? Nobody in here is an 83. We have the ones redheaded stepchild with the Casio, and I can help you. I figured that out today. So, do you know how to at least enter information in? I think you hit the stats. Like, we're going to enter all these shoe sizes. No. You would want to do what we're going to do. You can, but what if I give you 100 numbers? Because it's not the average I could do, the mean the median I could do, but we're going to get into some stuff that you want your machine to help you. So if you'd like to come really quick, I can show you as we do so. Everybody, once again, I hit the stat button. We're going to go to edit. Notice I have stuff in my columns, so I'm going to go up. Now you want to hit clear. Don't hit delete, but hit clear, and that gets rid of it. Another way to do it is watch how I can get rid of this list is I go stat. See where number 4, it says clear list, and that was L2, so I hit second number 2, and notice it says it's done. If I went back into my stat edit, everything's clear. I just wanted to show different ways to do so, okay? Is everybody good with me? All right, I do need somebody because if I flip back and forth, that would take forever. So everybody should have this written down. Anybody want to be my spokesperson as we enter this? Yeah, the numbers. Larissa, you got it? So 13. $19? I was going to say, I didn't think it was 19. That's a big A foot. What was that last one after 13? Okay. Oops, hold on. 7. All right, so notice. I know. Okay, so right now, guys, look, there's 22 elements. Did you put yours in? Were you able to? Okay. So what we're going to do now, if you'd like to come up here, I'll show you how to do the next step. One thing I would like to do, I don't know how you do it in yours, to be honest, I haven't found that. But we're going to go ahead and I want sort ascending because when you do the median, if you are doing it by yourself, you have to put them in numerical order, right? So I'm going to do sort ascending, so number 2, and that was list 1, so I go second number 1, close it off, and it says it's done. So if I went back in there and looked at edit, hot dog, we're in ascending order. So that's nice because now it's ordered it for us, right? Which, if we were finding our own median, that would take some time, wouldn't it? And I always miss a stupid number. Okay, but everything you're going to do today, guys, is calculator based. So we're going to hit stat, edit, 1 var stat. Now, here's the important part. L1, that's where you put your stuff. So go, once again, I'll do it again. Stat, calculate. Did I say edit? Oh, sorry about that. Calculate 1 var stat. Now, where did you put your information in? I had it in L1. Nobody in here has an L. Did everybody pull up to this page? Except for Tad. Which calculator are you using? Okay, so you're just going to have to go L1 after it. Okay. Now, frequency list. This is not a frequency list. Okay. We could do it as a frequency list, and I'll show you in just a moment how that would work. But I'm going to hit clear on that one to get rid of that because I don't have a frequency list this time. I just put all my info in. Does that make sense? But if you were, sometimes it might be easier. So like GPAs of this school, right? Maybe they have all the list of the GPAs, and they go, okay, this is a 2.99, 2.88. You get what I'm saying. But then they say, oh, well, 20 kids have a 2.99. So what they would do, let me hear you just talk about it. On your stat edit, I'd put 2.99, and then over in list 2, I'd put how many people there were. Does that make sense? Is everybody with me on that? That's how you would do a frequency list. So you don't have to write out as all those numbers. I could have did this, like for example, in L1 I'd put 5, and in L2 what would I put? 2, because there's 2 of them. Does that make sense with everyone? Okay, and I'm sorry about the yellow. We have a month. Really only 3 more lessons. After today, we only have 3 more lessons. 3 more new topics. Everything else will be reviews and tests. That's good, right? You ever think about it in that way? No? Okay, shut up, Roberts. Let's go on. Okay, so stat, edit. Wow, what the hell am I doing? I don't know what I'm doing. Stat, calculate, 1 bar stat. We do not have a frequency list, so we just hit enter, enter, enter. Now, once again, Brady, just make sure you hit L1. And if you were going to have a frequency list, you'd go L1, comma, L2, and then close it off. Make sense? Okay. All right, here we go. So our average foot size is what in females? 10.68. Good. If you have a different number, that means you did something wrong. And sometimes what happens when you put in information, like when I hit 11, I hit 1 twice, but it only recognized it once. So I had to make sure. Usually that's what I have a hard time on the test, and that's what usually people get wrong, is they miss a number, because this test is going to be basically 100% calculator. So when you make a mistake, I don't know how you made a mistake. I don't know if you know what you're doing. You know what I mean? So be very, very careful when you're entering your information. Okay? All right, what does X bar mean? Average. Okay, X bar on your calculator means average. Now, if I scroll down, okay, some of those other stuff up there is important. We'll get to it when we need to. But as we scroll down, MED represents median. So what did that mean, guys? Technically it was the middle, but we had an even amount, so they had to find the average of the innermost term. And those innermost terms were 11 and 12. Does that make sense? Most likely. Or 10 and a 13. I don't know. You get what I'm saying, though. X bar is mean. Okay. What do you guys remember about in the past about min X, Q1, median, Q3, max X? You guys should have learned that before. Interquartile range would be 13 to 9, which would be 4. Interquartile range would be from 13 to 9, which is 4 units away. So that's not what I'm looking for. How many of you guys remember box and whiskers? Right? This information is the information of a box and whisker. So let's go ahead and write that down. Min is 5. Quartile 1's 9. Median's 11.5. Should be just writing this down so we don't have to go back to our computer, or I don't. Do this for me so I can just look it up. Okay, and max is 14. Okay, so, say what? You don't know what box and whisker means? Well, you're going to learn right now. So, first off, what was our average? 10.68. Is that a correct statement? Okay. What is our median? 11.5. What was the most number that popped up? Let's take a gander. I've been told the yellow doesn't pop up, so I'll do a red here. So it looks like 13 is. I have 5 of those. Does anybody else see something more than that? Where's the other? Oh, right there. Nope, nope. That is definitely not. Oh, mine, huh? Okay. I don't think I see anything others more than that. Do you guys? So our mode would be 11. And notice, guys, 13. It's an 11 in men. That's what I keep thinking. Because the whole day, my mode's an 11. Like that is the common shoe size. But we were in men's last time. Does that make sense? So therefore 13 is still an 11 in men's. That's why I keep doing that. Sorry about that. Okay, so a 13. Okay, that is our mode. That's the thing happening the most. So, Taylor, what a box of whisker looks like is this. Sorry, I'm just drawing it. That is an example of a box and whisker. Now, let's go ahead and talk about this. What does this one represent? That is the min. That is the lowest point. This represents quartile 1. Does anybody know another name for quartile 1? What does quarter mean? A fourth or 25. This is the 25th percentile. It is also the median of the min and the median. Doesn't that make sense? If half of your data is to the median, well, quartile 1 would be the median of the first half of the data, right? What do you guys think quartile 3 is? 75 percentile. Now, do you guys really understand what a percentile is? Because when I was young, I really didn't. A lot of you guys just got back your ACT data, right? And on it, it told you, oh, you're in the 92nd percentile, or you're in the 50th percentile, or 57th, or so on, right? Do you guys agree with that? You guys remember seeing that information on your test when they have it? Not on your test, but when they got your scores, okay? I used to think that means I got a 75%. I'm like, I sucked, you know? But what does that really mean? Does anybody know? Yes. 92nd percentile, that means people. Out of 100 people, roughly, you beat 92 people. You got 8th place. Like, for example, on my GRE, I don't know if you guys know what a GRE is. A GRE is basically the ACT for grad school. Okay, a lot of people take that to get into grad school. When I took it, I got 100% on my math, but I was in the 92nd percentile. So what does that mean? 8 other people out of 100, roughly, out of our data, also got 100. Does that make sense? Because if I'm getting 100, and I'm only in the 92nd percentile, that means 8 other people out of that 100 would have also got the same scores, right? Does that make sense to everybody? So, yeah. Yep. Yeah. Anyway, does that make sense to everybody? Are we okay? Okay, what's the middle one again? That's the median. And then, Taylor, the last one, I think you're the only one that didn't know this, is the max, meaning you've never seen one of these, right? Everybody else seen this somewhere? Okay, so, by the way, what's another name for the median? The 50th percentile, right? And that should make sense. It's the halfway point, so 50th percent. 50% above, 50% below, right? Okay. Anyway, we are going to talk about percentiles in a little bit, but let's go ahead and actually draw our box and whisker. When you draw a box and whisker, you actually have to write out all the numbers. What was our lowest number? 5. So 5, 6, 7. What was our highest number? 8, 14. Okay, so our data is our lowest number is 5, highest number is 14. Where was our quartile 1? 9. Median was 11.5. And quartile 3 was the 13. Now, this is actually pretty cool to see. You might not really understand, but this does tell a story. Because each of these represent a percent. 25% of our data is here, 25% of our data is here, 25% of our data is here, and 25% of our data is here, huh? that make sense to everybody? But notice, are they symmetrical? So because they're not symmetrical, that tells us some stuff. Notice 11.5 to 13, 25% of our data is between 11.5 and 13. 25% of our data is from a 13 to a 14. That means there's a lot of those. I've actually seen a box and whisker where the median and the max and quartile 3 were all the same number, because that had a lot of those specific data points, right? Does that make sense to everybody? Okay, is everybody with me on that? Now, if Shaq was here, and in there, once again, our max would be a lot farther, but probably quartile 3 to quartile 4 would be a very long distance, right? Is everybody with me on that? Okay. So this can show a little bit. Notice, hey, there's not as many numbers between 5 and a 9, because that's a long distance between it compared to the other ones, huh? You see how we could kind of analyze a box and whisker a little bit? Okay. Any questions about a box and whisker? Anything about finding the mean, median, or mode? Okay, let's go on to the 20. Let's say we were looking for my 92nd percentile. Let's think about that. So, like I said, I got a 92nd percentile. Okay, but in our data, the 92nd percentile, I can't remember how many it said, but it actually told us on there. Does anybody look at our data and see what it came up to be? Do you guys see where it says N right there? That means that's the number of terms there were. There's 22 things that we inputted. So, with that being the case, on my data here, where am I at? Where am I at? Where am I at? Where am I at? Uh-oh. Right here. Okay, so I'm going to times 22 by actually 0.92. Somebody do that for me. Now, by the way, this is kind of like the elementary or definition of percentiles. There is a more specific way. I'm not sure how to do so, but this suffice. This is very suffice for what we need to do. Somebody tell me I get what? 20.24. Okay, so the 92nd percentile, let me show you what that means. Does that mean that shoe size is 20.24? What does that mean, Daniel? Okay, so let's go back to this edit right here. This is why it's important to put it in there. Okay, notice as you see here, it says L1, 1. Notice when I hit enter, what does it say? L1, 2, 3, 4, 5, all the way down. What number am I going to go to? 22 and 23. Does everybody understand that? What was it again? 20 point what? So notice my 20th number is 14. My 21st number is 14. So what's the 92nd percentile's value? 14. So that means if I had a shoe size of 14, I would have it be in the 92nd percentile. Meaning I would beat 92% of the people in here. But also, we can also see that percentile can go a little higher, right? Because if it's also our max. Does that make sense to everybody? So really, you go down to the lowest number, what it is, and that's where they would find it. Okay? Is everybody with me on that? Kind of going at what I'm saying? So I could also say, hey, this number right here is the 20th term when I had a 14. So if I did 20 divided by 22, somebody do 20 divided by 22. What is it? So therefore, technically, a 14 starts at the 91st percentile. You're beating 91%. Is everybody there with me? Yes, ma'am. Okay, so what you do is always pick the number higher in our case right now. Like I said, this is the very elementary way of doing it. Is there a more specific way? Yes. We don't need to get into that. Once again, if you took AP Stats, it would get deeper into that conversation. Does that make sense? But always go to the higher. Why am I going to the higher? Because once again, the question on percentile is how many people did you beat, right? So if you go higher, then I'm beating everyone below. Does that make sense to it? So if it's not the same, go to the higher number. Any questions there on how to find a percentile if I asked you to? Could we do that? Just time the number of terms and times it by the percent that they're asking. That right there is 8-1. Not really hard, huh? That's about a fourth of your test. 8-2. Standard deviation and variance. When I think of curving a test, I think of the normal curve. And it kind of deals with standard deviations. We're not going to get into the normal curve today, but standard deviations helps makes up the normal curve. Like when you guys say, I want you to curve your test, you don't really want me to curve your test. What a curve on my test is using the normal curve, and that means 58% of you guys would pass and 50% of you guys would fail. I'd find the average. If you're below the average, you would fail. If you're above the average, I'd do you in certain grades. That's what a curve means. Nobody wants a real curve. Now, chemistry, or a lot of other ways that we've heard of curves, is usually taking a lower, or getting rid of a number or something like that, right? Those are curves, but just to understand, normal curve, this is really how somebody should curve something if they're saying the curve, but they could have their own definition. Does that make sense what I'm saying? We actually had a professor when I was in college that said, hey, do you guys want to be graded on a curve? He made everybody sign saying that they did because they wanted to. And they ended up, a kid had a 70% or something like the average was a 75. You got below a 75, you failed. That's what it was. And they had complaints. They're like, hey, you guys shouldn't sign stuff you don't know anything about. It was kind of a double standardy thing. It was kind of rude. But I don't know what it was in, but he made if they agreed to it, they did it. So that's kind of like their disclosure. He put it in their disclosure type of a thing. I don't know. Anyway, kind of mean. I just think, curves, lowering your standards. Just teasing. All right. So standard deviation, really what is standard deviation? I'm going to kind of do a nutshell. It does mean some other things, but I'm just going to kind of sum it up, okay? Each of you guys had different shoe sizes, correct? You guys are considered my sample. Are we everybody in the world? Are we saying the average shoe size in the world is a 10 point? No. You are just a sample of the population, correct? So your standard deviation, what that means is they take you guys and you take your value and subtract it from the average. So for example, my shoe size was a 13. The average was 10.68, right? How far away am I? I am 2.32 away from the average, right? Does that make sense? Who had a 5? Anybody have a shoe size 5? Okay. So you would have been negative 5.68 away from the average, right? So what we do, though, the standard deviations is it takes everybody's things and goes ahead and says, how far away is everybody on average away from the average? Does that make sense what I'm saying? It takes everybody and says, how far away are you? We square it. Okay. Add them all together. We divide by 22 because there's 22 of us, and you take the square root. That's what the standard deviation is. I'll actually write it right here in the notation that they have. Sigma, it's a baby sigma. I didn't draw it very well. It looks kind of like a bomb. Okay, is the square root of Papa sigma, because that's also a sigma, of x minus your x bar. Hey. And then we divide it by n. You will not have to use this formula, but that is what standard deviation is. It's basically the average distance away from the average. Got a question? All right. But once again, that's X bar, the average. Okay? So, but guess what? Our calculator will do it for us. Everybody go to the machine. Stat. And not edit. Nuts and crackers. I'm just going to hit second enter. Look right there. Technically, ladies and gentlemen, the S of X is what we're using. Because the S of X represents the sample. You guys were my sample. It's not the population of the whole world shoe size, right? Okay, so the S of X is sample. The sigma of X is population. Does that make sense to everybody? On your test, if they ever have a multiple choice test and they have both of them on there, that test writer should be shot in the freaking knee. Okay? Because that's mean. Because once again, that's an argument within statisticians again. Which one should you use? Right? But we're going to use S of X. So 2.9. Now, what does that mean? Okay? What standard deviation is the average distance away, but what we're going to show you is this. So here's our average. What was our average? 10.68? Yes? Okay. So in that normal curve, we have what we call our standard deviations. So from our mean, we go out one standard deviation in both directions. That is considered one standard deviation, going both sides. Even though it's doing two adding and one subtracting, that's considered one standard deviation. Does that make sense to everybody? Yes. So going both directions. Now, ours is 10.68. What was our standard deviation? 2.9. So let's go 10.68 plus 2.9. What would we get? 13.58. And if I subtracted 2.9, I would get 7.78. Did a lot of our shoe sizes fall in between 7.78 and a 13.58? Yeah, and actually that number should be roughly 68%. We'll come in to talk about that next time. Okay? But two standard deviations, so that means going off of this number and adding to that number, that distance is called two standard deviations. What would that be? Adding 2.9 to this would be 16.48. And if I subtract 2.9 from this, this is a 4.88. Is all of our data within a shoe size of a 4.88 and a 16.48? Yes. Okay, so that took two standard deviations to cover our data. Most of the time, the answer is 3. Most of the time. And I'll explain these reasonings later in the next homework next time. Okay? Typically it's 3. I've only seen it once where it's 4. Once is rare. I mean, not once. 4 times is rare. Very, very rare. Okay? And once again, next time I'll explain why. I should do these two together instead, but I didn't. Yes? I don't know. You could figure out if it's beyond a certain amount. But, okay, let's ask this question. In Europe, right? If you guys ever seen on your shoes, their sizes are like 44. You guys ever seen that? So, let's just say like I'm shoe size 11, but in Europe I'm 41. Let's say they just add 30 to everybody's American shoe size. Would that affect the mean? Would that affect the average if I added 30 to everybody? Yeah, because right now I'm at 10.68. Guess what the mean would be? 40.68. Because I'm just going to add 30 to it because it just added everybody's up. It's just going to still all be the same difference apart, aren't they? Would the standard deviation be any different? Not at all, because they're still the same equidistance away from the mean, right? Does that make sense to everybody? So what really standard deviation does is it's talking about grouping of your data. Okay? Now, variance, I have no idea what the hell they use variance for. I don't know. But be aware, variance is just your standard deviation squared. Okay? I want to say that's it. Okay. I would prefer to jump on that 10-7 stuff next time, just because then we have due diligence on it and not have to rush them, because I have 4 examples I want to go over. Is that okay? And then by that time, usually you guys are able to come back in and you'll see them as well. For today, it's a packet. So I'll be handing it. Any questions? Remember, what's our due date now? 21st.